Beanie Shells is a construction technology company. So we actually develop new ways of building. And it all started back in the 60s with my father, whose first patent, he developed 250 in his name in his career, which is still ongoing, was one where he would start with a circular foundation and then over a matrix of reinforcement steel, he would pour wet concrete, and then with 0.5 psi of air pressure, so low air pressure, he would inflate a building before your very eyes of up to 40 meters, 120 feet in diameter. So quite an extraordinary thing to see as a little boy, your father doing. And I sort of followed in his footsteps. He ended up developing a suite of construction technology systems and is sort of a major pioneer, a major player in the world of construction technology. Now, I say that almost mischievously because truly there isn't many people in the world of construction technology. When you compare construction technology to something like communication, go way back now to the Roman times, and communication for them was a backbone of how to keep this gigantic empire together for as long as they did. And the network of roads and these couriers would make that happen. Obviously, a lot has happened since then. You had the printing press, the newspapers, telegraph, radio signals, short and long wave, television, and then the internet, until we get to this extraordinary device that we all have in our pockets, which is obviously the smartphone. You take a smartphone, you give it to a Roman courier, and you blow his mind. I mean, this is something absolutely from another planet. Another thing the Romans were very good at was construction. And of course, they had cranes, they had concrete, they used modularization, prefabrication, all of these things that we think of as being actually quite contemporary were developed by them. So by contrast, if you take a Roman builder and you put him on a modern construction site, he wouldn't be that disorientated. And, that may be amusing, but in a sense, it's also extremely tragic because the fact that we as a industry have not evolved practically at all is a real problem. We are supposed to be providing shelters, and yet those shelters are not safe enough. The column to beam connection is the weakest connection you could possibly use, and that's why there are no squares in nature. We are the biggest polluter, adding almost 40% of the world's CO2, and that's a major failing in my mind. And on top of it, our buildings are far too expensive, leaving 25% of the world's population homeless. So if you were to look at our report card, and obviously there's a lot of teachers in the panel, you'd have to give us a pretty low grade. So that's why I sort of decided that it was important to follow my father's example and look at different ways of building and have that inform the design, especially with new exciting typologies like the tiny home. So to illustrate, this is a system that I came up with about 10 years ago. You start with a slab on grade, concrete slab on grade, and onto that you attach what we call a pneumoform, a pneumatic formwork. And you inflate that, again, using very low PSI, 0.5, similar to what you use when you smoke a cigarette. And you put your reinforcement steel, which is regular rebar, 3/8 inch, you can buy it at Home Depot. Once that's set and the inspector has come and certified that this is per the engineering drawings, you use shotcrete and you apply the concrete. Once the concrete is secured, you can actually deflate then the pneumatic formwork and reuse it a lot of times, even 50 times, maybe more. But what you're left with is this very, very efficient structure, efficient both from a structural and environmental and cost perspective. Here's sort of why. From a structural efficiency standpoint, we all know eggs work very, very well in terms of distributing their loads. Well, shells do the same thing, especially if they're monolithic. So they transfer loads incredibly efficiently. having them be incredibly efficient with earthquakes. Of course, fires, there's nothing to burn, so it goes right over you. And similarly, because of the aerodynamic shape, they're a lot safer in high winds and floods. With regards to green, as we'll see, it uses much less material, but which impacts the carbon footprint, but the life cycle footprint is really the biggest matrix that you use in homes because they're supposed to last 75 to 90 years. And when you have a monolithic, single material, no connection shell as your building envelope, it's as high efficient. It provides you essentially passive home level efficiencies out the door without having any extra expenses. You just have to insulate that concrete according to the temperature zone in which you are building. And then, of course, in terms of costs, which is critical, the two biggest line items in construction are material and labor. And when you use very little material because thanks to the structural efficiency of the structural system, you need less, and less labor because you're sort of letting nature do the heavy lifting with the air pressure. You have a lot of winds, and you can cut costs dramatically. We then looked at how one might apply this to the tiny home typology, and in doing so came up with another building system, a new way of building that doesn't use air pressure at all, but results in a very effective building that has all the advantages of a thin shell structure. We feel that if you site build rather than prefabricate, you're working in the right way, just because we feel that the building envelope itself is too big of a module to transport. On the other hand, you can prefab at the smaller level, and you can have a prefabricated MEP core, so mechanical, electrical, and plumbing core, that literally slides in. It can be factory built, so it's high quality components that slides in, provides the majority of the spaces and intelligence for the building, and makes it a lot sort of more efficient in terms of its cost and its quality. The buildings, have high ceilings, conform to regular real estate footprints, and are quite elegant, and they naturally ventilate and provide airy spaces that, interestingly, can be extremely flexible because the only structural component is actually the building envelope itself. There's no need for columns or beams at any size in this sort of way of thinking. You can cluster them together in little neighborhoods. You can scale them up. This is a 2,000 square foot ADU typology on 2 floors. You can finish them in a variety of different ways. You can combine them to create quite interesting architectural forms. And one of the things that we've been looking at for some time, and is one of our major focuses, is low-cost and disaster relief housing. And the idea that everything is site-built, using local materials, local labor, plays into that. So these are very scalable and can provide self-help solutions in those kinds of scenarios. So to recap what we're doing, looking at how we build, to build safer, to build greener, and then to build more affordably. And then obviously looking at how we build faster buildings using local materials and local labor. We build at a variety of scales, and I appreciate the opportunity to share what we're doing, and looking forward to all the questions that might be coming in.
Many thanks, Nicolo. I especially like that last part about building tiny affordably. So we'll get back to that when we get to our Q&A in a while. So that finishes the first part of the webinar.